Hi there, welcome to your lesson on completing the square. This is a key topic in quadratics. Let's get started. Alright, let's begin with solving quadratics. Let's say we had a standard form quadratic like this and somebody asked you to solve that. As you know, when we solve, it means we are making y equal to 0 and then solving for x. In other words, on the graph, we're looking for the x-intercepts. With a normal trinomial like this, the standard process is to try to factor it. So that one does factor, it factors into this. That allows us to find two solutions. We set each factor equal to 0, so we get one answer is -2, set the other factor equals 0, and another answer is -3. So that's kind of our normal approach to solving quadratics, especially if they're trinomials like this. Let's look at another one. Let's say we had to solve this one. Again, begin by setting y equal to 0, now you have this. Now this can be factored. Maybe you're thinking it factors like this. This is called a difference of squares and it factors like this. So now we have two factors, set each one equal to 0 and solve and you get two answers, 3 and -3. However, this one, let's look at it another way because looking at it a different way is going to help us with our topic in this video. So instead of going right to factoring, we're going to look at that and say, hey, I can just move the 9 over to the other side. So now I have x squared equals 9. And that you can solve by taking the square root of x, because if we take the square root of x and the square root of 9, we have our answer, right? Notice this we can do it this way because we don't have x squared and an x thing. In a trinomial, when we have x squared and another x part, we need to factor like that. But here we can just go straight to this. Now take the square root on both sides, square root, and as you know, when you're solving a algebraic equation and taking square roots, you need to put plus or minus here. So square root of x squared is x, but square root of 9 is plus or minus 9. And therefore our two answers are plus or minus 3. And that makes sense if we go back to here, because we're saying some number squared equals 9. Well, 3 times 3 makes 9, but -3 times -3 also makes 9. That's why we have the two answers, and that matches our two answers we had here. Okay, let's look at this one. This one's very similar to the one we just did. There's a little more happening, but notice the format is the same. We have x squared and we have some number, but we don't have an x. We don't have an x term like this one here. So that implies that here we don't have to worry about factoring. We can just proceed with this kind of process. Let's try. So first set it equal to 0. Then I can move this 30 to that side, move the 30 over there. So I have 5x squared equals 30. Divided by 5. X squared equals 6. And now I'm at the same place I was here. I can take the square root of both sides and get two answers. X equals positive root of 6 and x equals negative root of 6 if I take the positive and negative versions of that. Those are two answers. We can leave them like that or get the decimal values, but it's fine like that. Okay, one more. Let's say we have this equation. So now let's notice something. We started in standard form here, but this is now a quadratic given in vertex form. So a lot of students make the mistake of thinking, hey, if I'm going to solve this, I'm going to multiply x plus 1 times x plus 1, and I'm going to multiply that out, expand it, make it, basically turn this into standard form. But that's the long way. If you turn this to standard form, you might get to a standard form equation that you cannot factor. And we'll notice with this one in a moment that it can't be factored. So let's try this a different way. I want you to notice that this is just like this. We have 2 times x squared here, x plus something squared, but it's still x squared, and then minus a number. So it's just like this. So set it equals 0, move the 5 over there. Oh, sorry, I was just pointing out here that these are exactly the same, right? 2 times something squared minus 5. Same kind of idea. So we're going to peel away the numbers around here first. Okay, so 5 moves to the other side, which I've put here. Then I'm going to divide by 2 to get 2.5. And now I have x plus 1 squared. I can take a square root of that and square root of this, right? So that's what I was showing here, that these are the same. We can just, when we have a vertex form, we can just proceed with this series of steps, unraveling it and then taking a square root. So take a square root here, x plus 1. Take a square root here, we have plus or minus root of 2.5. And finally, you can move the 1 over to that side. So x is just equal to -1 plus that, -1 minus that. Okay, take a close look at that. Pause if you need to. Make sure you understand what happened here, because this is the heart of what we are looking at today. Alright, so one key conclusion there is when we have a vertex form quadratic, we can easily solve it without factoring. We can just follow this series of steps to solve it. We don't have to worry about factoring like we did here. So the question is then, is there a way to change standard form to vertex form? Because if we can change every standard form to vertex form, then we can always solve it like this. Let's take a look. So these are our forms of quadratics again: standard form, vertex form, intercept form. So today we're going to focus on taking standard form, making it into vertex form so that we can easily solve it. Okay, let's begin our discussion with perfect squares. A perfect square is a square. It is a rectangular shape or quadrilateral, which has sides that are equal in length. So here we have 5 by 5, so it is a perfect square, and we know the area would be 5 times 5 or 5 squared. Let's begin with another one here. We have now an algebraic square, x plus 3 by x plus 3. It's still a perfect square because the sides are of equal length. And the area of that would then be x plus 3 times x plus 3. That can be rewritten as x plus 3 squared. Just like we wrote 5 squared here, we can write x plus 3 squared. If you took that further and expanded that algebraically, if you multiplied those, you would get x squared plus 6x plus 9. That is called a perfect square trinomial because it is a perfect square. We can see it here, x plus 3 times x plus 3. So this is a perfect square. This is a perfect square trinomial. It's been expanded. We know that this makes a perfect square. We can see it here. Now notice some patterns. Notice this x has been squared to become x squared, and this 3 has been squared to become 9. And the middle number is like 3 times x times 2. So the middle number in a perfect square will always be that thing times 2. Remember that. So if you're going backwards, if somebody said factor this, you could say, oh, I'm going to factor this. This is going to become the square root of itself, 3. The square root of x is x. And then we have plus in the middle here. Let's try some more like that. So that's a pattern called a perfect square trinomial. It looks like this: a squared, b squared, and in the middle 2 times a times b. So see if you can recognize that as that. Something squared here, something squared here, and in the middle 2 times those two parts. So this one I'll help you with. Our goal here is to factor this. This is a perfect square trinomial. We're trying to factor it. It should factor into x plus 7 squared because we take the square root of 49, we take the square root of x, and the middle number we should notice is that times that, which is 7x times 2. So it only factors like this if that middle one you can confirm is 2 times those two things. Alright, second one, try to factor it. Hopefully you got x plus 6 squared. Again, 6 squared makes 36, x squared makes this squared makes x squared, and in the middle we have 6x times 2. Alright, try this one. X plus 4 squared. Great, we're taking the standard form and changing them kind of into vertex form by noticing they're perfect squares. Okay, now we're going to look at the negative version of those. All that has changed is we have a negative sign here. So what do you think the factored form of that's going to be? It's x minus 5 squared. So same rules, we take the square root here, take the square root of 25 here, but now we see a minus, so this has to be minus. Alright, how about this one? X minus 6 squared. And last one, x minus 2 squared. So hopefully after those 6 you clearly see the pattern. Perfect square factors into something like this. Alright, so let's take that a step further. Now we have an equation we're trying to solve. We see standard form here, we see 11 here. In the past, we would have taken the 11, moved it over here, and gotten 0 here, and then tried to factor maybe or solve. But if you tried that here, you'd notice this. If you move the 11 over and got 14 here, you would notice that that doesn't factor. So if it doesn't factor, let's try the technique we were just doing. It will always work. So look at this. Is it a perfect square? Can you factor it? So you should be thinking x plus something squared. Can this be factored? Yeah, it is a perfect square. So what should that be? Equals 11. And then the next step, if you're trying to solve this, is take a square root here, take a square root here. So if I take a square root here, x plus something, and over here, plus or minus the square root of 11. So go ahead and finish that one off. What's that going to give us as our answers for x when you solve it? Okay, check your work right here. That is a perfect square, factors into this. Take the square root on both sides, and then move the 5 over, and you have 2 answers for x, plus or minus root of 11. Try the same thing on this one. Okay, and check your work carefully. Alright, now let's look at this one in a different way. Let's say we looked at this way in terms of graphing. So we have here one equation right here, y equals that parabola, and on this side we have another equation, y equals 11. Basically we have one function and another function, and we're saying when is this function equal to this function, or when is this equation equal to this equation. So those are two equations. Put them in your calculator, graph them together, y1 and y2, right? Enter both equations and see what you get. And then find where they intersect, because those should be the answers we get for this. So here is our parabola graphed, this parabola, and here's the line y equals 11 graphed. It's a horizontal line. And notice they intersect here and here. If you solve those 2 points of intersection, you should get these two answers. Those answers are exactly the answers we have here. When you do -5 plus root of 11 or -5 minus root of 11, you get those two answers precisely. So make sure you understand that key connection there. Okay, let's move on from there. Let's look at a standard form equation and how to change it to vertex form by this process called completing the square. So here we have a standard form. We notice that it's not a perfect square. So here's what we're going to do. We're going to move that 1 over to this side. Keep the x squared and the 10x here. Then here, we're going to try to make a perfect square. The way to do that is to do b over 2 squared. This formula always works. So b is 10 over 2 squared. 10 divided by 2 is 5. 5 squared is 25. So what we do is add 25 here and add 25 here. We added on both sides to maintain the balance. And by adding 25 here, we've created a perfect square. So this formula will always produce the number we need for a perfect square. This now factors into x plus 5 squared. Over here we had 26. Now move the 26 over and we have vertex form. Standard form changed to vertex form. Let's try another one. Try this one here. Okay, here we moved the 7 over because it was not a perfect square. Now do b over 2 squared will give you the number we need to add here. -6 over 2 squared, 9. So we add 9 here, add 9 here. Now we have a perfect square, which factors into x minus 3 squared. Move the 2 over, we have vertex form. Standard form into vertex form by this process called completing the square, and there we have it. Okay, let's look at solving by completing a square. If somebody gave you this standard form quadratic and said solve it, you would begin by setting it equal to 0, so making that y into 0, and then maybe trying factoring. So let's try. a times c, b. a times c is -4, b is -2. What two numbers work here? Well, there are no numbers. We cannot factor. And that's often the case. So far we've seen lots of quadratics that can be solved by factoring, but there's so many that cannot. So we cannot factor. We're going to try completing the square. So is this a perfect square? No. So I'm going to move this 4 over here. Then I'm going to look at this and do b over 2 squared. So -2 over 2 squared equals 1. So now I'm going to add 1 here and add 1 here. This is now a perfect square. So it factors into this. Solve this by taking the square root on both sides and getting this, and then move the 1 over like this. We have two answers of x equals 1 plus that and 1 minus that root of 5. Pause if you need to, make sure you understand the process carefully. Okay, try these three. A. 9 is the number we added when we did b over 2 squared. Now we have a perfect square, factors, solve. B. Okay, check your work here. It was not a perfect square, so 21 was moved over. Then 4 was the number we added when we did b over 2 squared. Check your work. And C. Great, check your work carefully right to the end here. Okay, let's look at this one. This one's a little different. Set it equals 0. Try factoring. A times C is -6, B 28. Are there two numbers that work? No, we cannot factor. Therefore, we're going to try completing the square. Here's how we're going to do it. Move the 3 over. Now look at this. Before proceeding, this one's different. The a value is greater than 1. We have to do an extra step here. Factor out the 2 from both of these to get this. Now make this a perfect square. So b over 2 squared. Well, 14 divided by 2 squared is 49. So we're going to add 49 here. But we're not going to add 49 here. We're going to add 98. The reason is we have 49 times 2 on this side. So that's really a 98. So we add 98. Proceed. 101 equals that. Perfect square factors. Divide by 2 on both sides. Take the square root on both sides. And then move the 7 over to get two answers. Pause. I moved quickly. Check your work carefully. This is very important that you understand this process. And finally try these two using the same process. check your work for that one. And try B, check your work for that one. Alright, hope that end